Hello, everyone. Welcome to this new series of talks. We have this evening a series of 3 talks from our sponsor, Madrid Space, International Space University, and Aistech Space. We have the pleasure of having with us David Orgaz, co-founder and CEO of Madrid Space. Also, Nassim Bové, head of the admission and alumni affairs at the International Space University, and Josep Pino, CTO at Aistech Space. They will be explaining a little bit more about their companies and universities, and also they will explain how they are contributing to humanity and the sustainability of the Earth through the activities they are performing at their companies and university. Please remember that every talk will last up to 20 minutes, and they will count with a presentation and time for the QA. So you will be able to ask all the questions you have through the Q&A tab in Hopin for this particular session, and we will be more than happy to answer all of them at the end of the presentation. Also, we have some more interactive presentation. So David Orgaz from Madrid Space will be addressing you some questions, and we are expecting your contribution, your feedback and answer through also this Q&A tab, and we will be analyzing your response at the end of his presentation. So I will introduce now David. He will be our first speaker. So welcome, David. Thank you for being today here with us. I give the floor to you. Please introduce yourself and talk us a little bit more about Madrid Space.
Okay, hello. Thank you very much, Pilar. And the first thing I would like to say is that thank you very much for the organization of the event. And yeah, it was a pleasure so far, all the interactions with you. And thanks to all the people who is attending this presentation. So yeah, let's introduce myself. As Pilar mentioned before, I'm David Orgaz, CEO and co-founder of Madrid Space. Apart from my role at the company, I also have the opportunity from last year to be associate professor at the university, Carlos III, here in Madrid. So I consider myself a really technical guy. I would like to tell you in a nutshell what we do here at Madrid Space, and also one of the particular projects that we have under development. First, in a very short sentence or a couple of sentences, I would like to explain the core of our company. We are a company focused on the thermal and structural problems. We address thermal and structural problems for space structures, space applications, and our motto is to solve them in a very efficient way. So these disciplines that we cover, the thermostructural problems, are related to structures, okay? But apart from the analysis activities that we perform, the services that we provide to our customers, we also perform design and also CFD calculations, okay? In our team, we have more than 30 years of combined experience, even if we are a very young team. And yeah, apart from the services that we provide to our customers, we are also developing technologies in order to basically improve the efficiency of the platforms, of the satellite platforms that will be incorporating our technology. I will go through it afterwards. We had from 2018 the pleasure to be part of the ISABIC here in Madrid. We are now finishing our incubation period at the program. And just to explain a bit more about the competencies that we have at the company, As I mentioned before, basically the core of the company is orbiting around the thermal engineering. We perform design analysis. We can provide support to the test campaigns, define thermal ground support equipment. So we consider ourselves experts in thermal engineering. We also cover structural engineering, analysis of structures, bolts, bolted configurations, composites, etc., etc. As I mentioned before, we also cover the design part, both from the, let's say, traditional design, but we are really focused on these novel techniques related with additive manufacturing. Therefore, we master the algorithms for topological optimization and creation of structures which are really efficient in terms of mass, but also in terms of thermal properties, thermal characteristics. Apart from that, we cover the branch of the computational fluid dynamics. So we can perform re-entry analysis. We can also cover the propulsion systems design for rockets or different launch vehicles. Our heritage is, I would say, really powerful. Despite being only 5 years old, we have participated in many ESA, NASA, and JAXA missions, very relevant over the last years. And yeah, we have performed activities in different activities in these missions that I was showing before. So thanks to our knowledge and our background in thermostructural design and thermostructural analysis, we identified a clear trend in terms of temperature increase in electronics on board satellites. We see that trend due to the miniaturization of the components and also the how demanding the missions are for the electronics, that yields a temperature increase on this kind of components, which is very risky, and it's limiting also in terms of the value that you can extract from your satellite. Imagine that if you consider that the bottleneck of your satellite in terms of providing data and therefore providing value is the power that it can handle, if you can increase that power, and that's something that you can do by decreasing the temperature of the electronics, you can therefore provide more data and more value to your customer. The solution that we are working on at this moment is to create multifunctional structures, taking advantage of additive manufacturing. Thanks to that, we can incorporate thermal solutions embedded into the structures, and that gives us a very powerful tool in order to decrease the temperature of the electronics that are mounted into these structures, because they can get rid of the heat way more efficiently than a traditional manufactured structure. To do so, we are developing at this moment porous structures in additive manufacturing. Here, I'm giving you some examples of this technology. It has been used on Earth applications, basically on implants, and basically also using titanium because of its biocompatibility with the biocompatibility of the titanium. Of course, there has been also some developments by NASA, for instance, and also here in Europe, there are some institutions and some companies working as well on this technology. And here I would like to highlight for some of you, maybe you have some expertise in additive manufacturing. Here I would like to highlight the main differences between the traditional approach and the approach that you have to follow if you want to develop a porous structure. Basically, the difference is that if you want to follow a traditional approach with additive manufacturing, you are basically trying to replicate the properties and the characteristics of the raw material. However, if you are developing a porous structure, the approach is completely different because by definition, you cannot have the 100% compactness of the original structure that you want to replicate. So that's a problem. It also has some advantages, but yeah, it's essentially different compared to having a traditional approach. To do so, to develop this porous material for the technology that we are developing, well, we have followed two different processes, two different approaches. One of them is focused on design, on designing locally the porous material, and the other one is related to the process, is related to tweak, to tune the parameters of the manufacturing machine of the 3D printer in order to obtain materials which are not fully sintered, and therefore you have an equivalent porous structure. Here I'm showing you some samples that we have 3D printed, replicating these porous structures. And yeah, the pictures on the left side are printed with the design process, and the picture on the right side is printed with the process approach. Sorry, I said design process. I meant design approach. We have performed some tests on the samples that we have printed, and we obtained really nice results in the sense that for some samples we were able to replicate the behavior that we were looking for. So we were able really to create and to manufacture a porous structure in metal. In this case, we were using aluminum. So that's the my presentation. Basically, the reason I was explaining you this technology that we are developing is because we identified that the technology and some applications that are used on Earth, on Earth application and solving Earth problems, can be used in this case to approach a problem on a satellite. So the questions that I raised before that I wanted you to address are basically related with this technology transfer, both in the upstream direction, but also in the downstream direction. And they are related with the potential applications that you see on Earth from space technology, space applications, and also the other way around. So that's pretty much everything from my side. Thank you very much, and I will be more than happy to answer the questions that the audience might have.
Thank you very much, David, for this interesting presentation, and also for illustrating how startups play a major role in innovation in the space industry, and also sharing with us all the new technology and processes you are implementing at Madrid Space. So we are running a little bit out of time to pass through all the answers to your questions from the delegate, but we have several questions that I would like to address to you. So we have one question asking, maybe there is a way to use solar cells to transfer solar power back to Earth. Super science fiction, but since it is higher up, the atmosphere will have less effect and therefore be more effective. Is something that we could think to have in the future? What do you think about this?
That's well, it's not really science fiction because I heard that some years ago. I don't know if it was Russia or China were thinking about using mirrors to take advantage of even more power from the sun in order to apply it on Earth to melt ice in the poles or something like that. Yes, but of course. I mean, we have to be careful with what we do. I mean, if it has a significant impact on Earth, might be, of course, dangerous. But particularly with the new technologies that we are developing in order to launch cheaper into space, we could potentially create significantly large structures on space and therefore take advantage on of them in order to apply potential changes on Earth. But of course, we have to be careful with what we do.
Thank you very much, David. Another question is, what about creating materials in a space and how their properties would be different, less porosity, or in metals, would it change the grain size and number of this location so it will create stronger materials?
There are already some initiatives, some experiments flying on the ISS on 3D printed materials, 3D printers to print materials. I guess that they are plastic materials, because for metallic materials you need powder, and you need to have gravity in order to put the layers on top of each other. But yeah, I mean, 3D printing in space at different scales is something that is a must, because in the future we will need 3D printing at a high level in order to create environments in order to survive on the moon, on Earth, or something like that. So that's something that has to be developed, yes or yes.
Thank you very much. So we have the time for one last question, and this comes from our entrepreneurs here within the delegates. So they are asking if you could explain a little bit more your experience with ISABIC project.
Yeah, it was in general very positive, and the main thing that I can say from ISABIC is that it's a perfect starting point for a company like ours to create more and more, let's say, prestige and being open for more opportunities. It can be public funding, private funding, or whatever. So it's like a quality seal that we have. And it's really hard for me to think about how we could have been reaching the level that we have at this moment as a company without the help of the ISABIC. So it was a perfect starting point for us, and I really recommend to anyone who wants to be an entrepreneur in space, at least to address and evaluate the incorporation to the ISABIC program at the different locations. If they have one ISABIC program close to where they live or where they want to have their company settled.
Okay, thank you very much, David. For all those that didn't have their question answered, they have your contact here on the screen. And I think you will be also on the event on Saturday, so they will be able to reach you on Hopin directly for more discussion on Madrid space and your experience. Thank you very much for being today with us, David.
Thanks, Pilar.
Thank you. Bye-bye. So let me introduce our second talk of this evening. We have with us Nassim Bové, Head of Admission and Alumni Affairs at the International Space University. He will tell us a little bit more about the International Space University and the opportunity it brings to this industry. Welcome, Nassim. I give you the floor. Thank you for being today with us.
Thank you very much, Pilar. First of all, I'd like to thank very much Space Generation SGAC for inviting us to this event. We have been ISU. We have been long-time partners of SGAC, and it's a pleasure to present here. So thanks to all the attendees. So I will make a quick presentation of the International Space University, and then we can take a few questions. Let me just take this. There we go. So what is ISU? It's basically international students from all over the world who learn from international faculty. And the idea is to give everybody an interdisciplinary understanding of space, not just space science and space engineering, but also space business, space management, space policy and law, all the aspects of space. ISU was founded in 1987 by these three young visionaries. We often speak about the three I's: international, interdisciplinary, intercultural. ISU is clearly a competitive edge to start a career in the space field. It's like we are a door opener to the space sector, and more than 80% of our alumni work in the space sector. About our programs, we have our Master of Space Studies, which is a one-year program in Strasbourg, France, one-year master. we have our space studies program. This one is the historical program, the one which started in '87, so that's 33 years ago. And this 2-month program is held every summer in a different country. We also have a program in the South Hemisphere for our friends from the South Hemisphere, and that one happens in January and February. It's a 5-week program. We have a program in Florida, and we also have a shorter program called the Executive Space Course. On this map, you can see all the space studies program, the summer program host sites from 1988 to 2021. So every year we are hosted in a different country. We have been many times in North America, as you can see, many times in Europe, of course, where we have like our headquarters are based. We have been a few times in Asia and in the South Hemisphere, but now we have our dedicated program. More importantly, our next programs in red, you can see them here. This year, exceptionally, we are having the program in 2 locations, in Granada, Spain, and Strasbourg, France, because we have to have smaller groups to adapt to the current situation. And the program is also taking place online for those who cannot travel at the moment to the site. And for next year, we'll be in Lisbon, Portugal. So these are the upcoming locations. The latest one, I have a few stats from SSP19. We had 127 participants from 37 countries, so this is quite typical. As you can see, really people come from all over the world. In terms of backgrounds, about half of our participants are engineers, and then the other half is composed by all the other backgrounds, which I mentioned before. In terms of structure, the SSP, which lasts 9 weeks, 2 months, you have 3 phases. First phase, you have morning core lectures and workshops. Second phase, departmental activities. You can choose one department and focus on it. And then last phase is the team project. So our participants work on different team projects in 3 teams of 40 usually. The SSP departments. So after getting all the core lectures on all the space aspects, you can choose one department and really focus on it. So if you're an engineer, it might be good to take space business and management or something you don't know already. And on the other hand, if you're a non-technical person, you might want to choose a technical department to focus on it. I mentioned the Southern Hemisphere program, which is a shorter program in January, February, while the regular program is always in July and from June to August. So this Southern Hemisphere program happens in Australia, except this year it took place online because of the current circumstances. In terms of the master, it's a small master with about 40 to 50 students, also coming from all over the world. The backgrounds, you also have about half engineers and then 50% from other backgrounds. And in terms of structure, the MSS lasts 12 months with introduction to space. Then you go more in detail on all the space aspects. You also have team projects and individual projects. You have your electives where you can choose a la carte what you want to focus on. And finally, the internship, which you can do in any of our partner institutions, which include NASA. You can do your internship at NASA, at ESA, or any space company worldwide. In terms of team projects, it can be about space exploration, if you're into it, or it can be more about how to help the Earth using space technologies. So every year we have various team projects, and you can check our team projects on our ISU library websites. They are all available to consult. In terms of ISU facilities in Strasbourg, we have for radio astronomy an X-band antenna. We have a concurrent design facility to design our spacecraft faster and more efficiently. We have a tracking and ground station. So when our students are sending a nanosatellite, for example, we can follow it from ISU. We have a real Russian space capsule, a bit like the Soyuz. So hopefully one day we can launch it into space. And we have a self-deployable habitat for extreme environments, basically called the SHE. Basically, it's a simulation station to simulate future Moon and Mars missions, and it can host 2 astronauts to be. We have several research projects, including some currently in space in the International Space Station. And the last one is scheduled to return to Earth in January 2022. But it is on the ISS right now and designed by our students. We also have, for alumni who want to start their own space company, we have an ISU incubator and booster. So once you become an alumni of ISU, you can benefit from services to help you find funding. And we even give you free offices at the beginning so you can start your company. In total, the ISU alumni community since '98 and until 2021 has graduated more than 5,000 alumni from over 110 countries, as you can see on the map. Examples of ISU alumni include Jessica Meir. She's MSS 2000, and she is now a NASA astronaut. She has been to space, to the ISS already, and she might even become one of the female astronauts who will be sent to the moon. So we are very proud of her. But we have many alumni in North America, in key positions, in Europe, in Asia, in the Middle East, in Africa, in Oceania, in Latin America. On this slide, you can see many of the organizations which actually employ ISU alumni. We have many alumni working for NASA, many working for ESA, of course, and then the Chinese Space Agency, the Indian Space Agency, the Japanese Space Agency, the Canadian Space Agency, the French one, the Australian one, South Africa, UAE, and many others. And in terms of companies, especially in the new space, we have alumni working for SpaceX, which everybody knows about, of course, Airbus, Boeing, Lockheed Martin, Virgin Galactic, Blue Origin, Planet, Spire. Actually, the founders of Planet and Spire are actually alumni of ISU. We are everywhere on the social media, of course. Please don't hesitate to check us on Facebook, LinkedIn, Twitter, YouTube, Instagram, etc. A word on Rsu Chancellors. The first one was the famous Arthur C. Clarke. Jean-Jacques Dordain was the next one, previously the Director General of ESA. Buzz Aldrin, the second man of the moon, was our chancellor for several years, and currently is Pascal Ehrenfreund, who was the DLR's president, German Space Agency president. Finally, I'd like to speak about the fees and the scholarships. The fees, which you can see here, might seem high, but the scholarships that we are able to offer are also very high. We are even able to offer some full scholarships for really outstanding applicants, and any candidate who is accepted to ISU can receive at least a partial scholarship, which can cover a big portion of this fee. So don't hesitate to apply. You will get the scholarship as soon as you're accepted. And we are quite generous with European candidates, especially because we have a lot of funding from the European Space Agency. So the deadlines are here. Please note that although the SSP theoretical deadline was 30 April, we still have a few seats, like a couple of seats available for this session of SSP 21, which happens in Granada and Strasbourg. So if you're interested, please apply online quickly, and you might be able to get it. Otherwise, we will welcome your application for next year in Lisbon, Portugal, or for another program. So thank you very much for your attention. I'm now ready to answer any questions that you may have.
Thank you very much, Nassim, for this presentation. It's actually impressive to see the level of alumni at ISU. So I think this will for sure encourage people to apply to your programs, masters and other qualification programs in the coming years. I have some questions. We have still time for a couple of them. So I have a question from one of the candidates. It's related to your latest slide. I've wanted to apply to SSP for a while, but the cost is high. There are scholarships available, but many are resolved after admission. What happens to a candidate that does not get the scholarship?
Normally, if you apply early enough, you will get a scholarship. Otherwise, you will have to defer your application to the following year. But normally, if you're accepted and it's not too late, we still have funding left, we will give you a scholarship. So just give it a shot.
Perfect. So the recommendation is try. The no is always there. You don't lose anything for trying, and you
Exactly.
can have
Applications are free. Yeah.
great opportunities. So we have another linked question to it. What is the best moment to go to ISU? What age range?
What age?
Range.
Oh yeah, okay. I would say as soon as you can, because we are all very busy. Sometimes we start a career and then we cannot go back to study anymore. I would say if you're just out finishing your studies and you have a free summer, go for it. If you have a bachelor degree, you want to do a master, do the master. Some people also work for a few years and then they come and join ISU, which is fine too. But really the key is to find the time. So I would say do it as soon as possible, and it will help you wherever you are in your career.
Perfect. So there is not a particular path to follow, is to find their own path for it. Okay. So we have another question related to it. What are the minimum requirements to be met to be eligible to participate in an ISU program?
For the space studies program, the summer program, you only need to have 3 years of university studies completed. And you can come. You don't need to have a diploma. But if you want to do the master at ISU, of course, you need to have your bachelor degree.
Okay, thank you. So another question to the row. How does a potential candidate submit a good application for ISU programs? Are there any suggested key points and things to keep in mind from a scholarship point of view to get selected?
You should explain very well your motivation, your passion for space, your motivation, why do you want to attend ISU in particular, how you think you can contribute with your open mind and international aspect in your curriculum to ISU, and to be a good participant and a good team player. So yeah, cover all this. Choose well your referees, because you will need to provide 2 reference letters, and stay informed about everything which is happening in the space sector.
Perfect. Thank you very much. So the time for a last one. What differentiates ISU programs from programs in other space university? What are the most important skills the alumni will get?
I think the most important is that you'll be able to network with the whole space sector. We have been around for 33 years, and our network is our strength. Our 5,000 alumni are everywhere in the space sector. They are in very high positions, especially in the new space. So once you join ISU, you'll be able to contact anybody in any space agency or organization, and it will help you immensely for either to find a job or in your career.
Okay, clear. Thank you very much. So I hope everybody enjoyed. For sure, you shared your contact details. If you have other questions that couldn't be answered today, please do not hesitate to contact directly Nassim. He will be pleased to answer. And I wish good luck for all of them that want to apply to the next programs. And hopefully you will get also the scholarship. Thank you very much, Nassim.
Thank you, Pilar. Thank you again to the organizers. You did an amazing job. Thank you.
Thank you very much. Have a nice evening. So now we pass and we introduce our latest speaker of this evening. We have with us Josep Pino, CTO at Space Tech Space. Aistech Space. So I will welcome with us Josep Pino. Hello, good evening. Thank you for being here, Josep. I would like, sorry, you are muted. Yeah.
Now, right?
Yes. So Josep Pino from Aistech Space, CTO, welcome today with us. Thank you for being here and present Aistech and all the opportunities we will see on your company. I will be pleased to give you the floor and know more about Aistech.
So hello, everyone. Well, we'd like to start thanking GAC for this amazing job that you're doing, especially to the team that has made this event possible. I know it's been hard and it has taken several delays, but you finally did it. And I know that doing virtually is not easy as well. So congratulations to everyone. I would like, well, to start my presentation with a question, right? What we're trying to do here at Aistech is kind of let's say something new we're trying to move forward the technology in the thermal imagery area. So the title of the presentation is will 2022 be the year of thermal infrared imagery? In order to answer this question, I would like to go through what is thermal infrared, because we are a bunch of people out there trying to come up with really nice ideas for this technology, and trying to get the best of this, right? So we have to answer also the question of why is important thermal infrared, and how us New Space are trying to reach that, this technology jump, bringing all these instruments down in size and weight. And finally, we'll tell you how we're going to do it here at Aistech, and why we think we are at the vanguard of the thermal technology. And finally, we're just going to give you a little hint on the key markets that we believe our technology will be tackling shortly in 2022. So starting from what is thermal infrared? Well, for those that you are not in this area, thermal imaging just spots heat instead of light. So it's one of the key differences between normal Earth observation missions that work in the visible spectrum and the ones that are working in the thermal infrared. So every object that is warmer than the absolute zero, it will be emitting this infrared radiation that our sensors and our images will be picking up. And the ranges on the infrared area that are acquiring that radiation are the middle wave infrared and the long wave infrared area, between 3 and 14 microns. So also there are other technologies, other imagers that are working on the near infrared and the short wave infrared that are closer to the visible spectrum. Those ones are not measuring heat, even though they are being used also to come up with, let's say, solutions that are monitoring some applications that are used on the thermal area. So what do we see are the key features of using thermal infrared? Well, first of all, they are illumination independent. So this is really important, and one of the main differences with the visible spectrum. So we can operate day and night. So there are no lighting conditions. And another one that it's a key factor as well is that it can see through smoke and light clouds. So that enhances that visible imagery. And at the end, one of the main reasons to use thermal is to monitor temperature and to monitor critical infrastructure. So on the image on the right-hand side of your screen, you will see an image taken from one of the satellites carrying that technology at the moment, flying in space using visible. Then making all the processing into the sphere, and we can already spot differences on thermal, let's say. And finally, that will be the same image processed on the bands that the Landsat 8 satellite is carrying. And you can see that here we are actually seeing the emitted radiance of this fire in specifically, the wildfire in the British Columbia. So where is this thermal infrared located in the spectrum? So as I was introducing before, we're looking at this medium wave infrared and long wave infrared, between 3 and 15 micron. And where Aistech Space image technology will move, it's exactly on the long wave infrared. We'll be focusing on that area only. So why is important thermal infrared technology? So basically, it's important because it actually tackles lots of important issues on Earth at the moment. Talking about global warming, talking about renewable energy, situational awareness, critical asset monitoring. We can actually be targeting areas on flooded areas, fire monitoring, water management, detection of new minerals, even spotting fish banks. So there are lots and lots of really key areas that we will be tackling, and this is so important for us. So in order to do that, what we understood at Aistech is that there was a lack of instruments in the thermal range. and not only there was a lack of instruments and satellites, but also they were having low resolution and low visit times. So there are some applications that they may be enough, but the others that definitely this is not the reality, and we need to increase that resolution, that visit, to make things happen. So here I just listed just the most important ones, like Terra, Aqua, Suomi, Landsat. They are key players at the moment, giving us amazing data. But we believe that New Space is here to tackle some issues in the market and trying to offer new points of view. Just here, okay, it's a lot of information, I know, but what we are looking at is only on the right-hand side of this screen, where we can see all the long-wave infrared bands that are being now used in space. And here are the same satellites that you've seen before. So we're talking about Suomi, Terra, Aqua, Meteo, Landsats. Most of them are retired. It means that only archive data is available for us, for the public. And there are others that are still operational and giving us imagery every day. That is really important as well. So we are looking at the right bands in our satellite only in that area, on the long wave infrared. So let's talk about what do we need to actually close the gap on the market in terms of resolution and visit. So here are two key points to discuss. So we believe the sensors are the key in this area that will make the technology jump into the future. And we know in the recent years there's been lots of developments on focal planes assemblies, on lenses, and even in materials. Here at the Aistech space, we're using really relevant materials for our imager. And basically, we came up with the question of, are we going to use uncooled thermal sensors? We're going to use cryo-cooled thermal sensors? And we had to decide where the technology was when we started the project about 3 years ago. So the main key factors for deciding one or the other were, speed at which you are acquiring those images, the resolution you will get out of those images, the sensitivity, so noise levels, the price, definitely, and the technical challenges. So we will get that technology in time for our mission. So here I just classified it in advantages and drawbacks. So cryo-cooled seems like it's a winner in terms of speed, resolution, sensitivity. So it looks like it's a better sensor, but there's a big drawback, which is the price and the technical challenge. Here, the uncooled thermal sensors seem like, for new space, the most convenient, let's say, approach. And I'm sure that cryo-cooled technology will come up and will be reducing in price, in dimensions, and everything. But at the moment, it seems like uncooled thermal sensors, they are more at the edge of technology and ready to be used. Another key factor is the miniaturization of the satellite components itself. So we're here because we need space, and we make use of technology like CubeSats. So small satellites that can actually be launched for like a fraction of a price of a what we call the all space satellites. No, platforms bigger than 500 kilograms and above. Our satellites, they will never be more than 10-15 kilos in weight, and they can carry as many sensors as you would imagine. In our case, we'll be talking about high-speed computers that can process data on board, and can only can download only data that we need. Not only that, but we can also put like a thermal imager into a 6U. So here you can see these three pictures. The three of them are here at Aistech. The computer on the left-hand side, our top-notch telescope, FM, and on the right-hand side, our 6U platform that will be carrying our first thermal imager into space. And finally, how we're gonna tackle resolution and components on one side to increase the resolution of the images, and then how you tackle revisit time. So revisit time can only be tackled by constellation of satellites. So at Aistech Space, we decided to go for a 20 satellite constellation that will give us an hour revisit time, providing this high resolution thermal imagery. So as I was saying, the 6U platform is our baseline at the moment, and this is the one that we'll be using for the launch of the first 2 satellites, starting at the end of this year, December 2021. But we're not the only ones, as I was saying in the beginning. There are a bunch of companies, not only in Europe but in USA, that are going to go into that range of the thermal between MWIR and LWIR, and like the GHGSat with some satellites in space, Constellation AR, Hydrosat, Kulog, that Satellite Vu, and Aurora Tech, that more or less are at our stage and still waiting for their first launch. So how do we believe that we are at the vanguard of thermal at Aistech Space? So as I was saying, Aistech is going to be the first of a kind high-resolution multispectral telescope that will not only include thermal infrared, but it will also include visible and a near-infrared channel into the same package. That will be possible within this 6U platform. As you can see here, there is a real render of our final satellite. We'll be the first commercial company in the world to produce such high-resolution thermal imagery. This is not possible at the moment, and we will try to be the first launching at the end of this year. We'll be launching the constellation into sun-synchronous orbit to have full coverage of the Earth, and we'll ensure that we'll have this high revisit time of 1 hour by the end of the deployment of our constellation of 20 satellites. And also, I wanted to highlight this. We are really, really happy and really lucky that CDTI here in Spain, they funded our project to develop this first thermal telescope with us. Obviously, the project is finished now, and we're just ready to launch by the end of the year. And I wanted to finish just giving you some key performance features for our thermal constellation. I talk about the revisit time, as I say, but anyway, here we have the key performance features, which are resolution of less than 50 meters on the thermal infrared area, and a resolution of better of 5 meters for the visible and near infrared. This is key for us. We are trying to get the best we can out of this telescope. And then we have the key operational features, which is really important to say that all the 3 images on the 3 channels, they will take it at the same time from the same area of the world. That's really important, not only for geolocation, but it's really important for information itself. You don't have to go anywhere else to find other images. You can take them with our same telescope. We can provide more than 120 images per day. As a starting point, it will go higher and higher. And finally, it's important to say that we will be operating not only at nadir as normal, but we can actually take images across track and along track.
Thank you very much, Josep, for the presentation. I think it has been very engaging taking a look on the questions. So I wouldn't like to finish without giving you a couple of questions from the delegate. I think it's interesting also to provide some answer to some of the main wondering they are sharing here with us. So I have one question relating to what level of resolution are we targeting in the future, and what that this technology will allow spotting in the future that is not possible today?
Sorry, but I think I missed something. Yeah, I was talking, but I couldn't hear.
So you were mentioning that
you were mentioning the presentation.
Yeah. So the problem is we are running a little bit out of time. Do you have other particular slide you want to share, or can we go to the questions Q&A?
No, I was going to go quick onto the key market targets, which are like a couple of slides, and I'm done basically.
Okay, if you can go. Okay, I give you a couple of minutes.
Apologies, I was talking and I don't know if you were talking to me.
No problem. So give you a couple of minutes and then we need to go very quickly for the Q&A.
Yeah, apologies, Pilar.
No problem, no problem.
I'll be fast.
Go.
So key market areas that we'll tackle with our satellite and our thermal imager is 5 hazards. So we'll use the thermal not only to tackle these, but to actually predict and mitigate future risks. So on the left-hand side, you can see a Lancet image, and then transform into a proper thermal image. That would be our products that you would see in the near future. Also, we have water quality and flooding, really important to know how the state of the water of our rivers and seas. And obviously, we have found like really good applications on the flooding area using thermal imagery. As you can see on the right-hand side, it is a flood on a river basin. And finally, surveillance. It's another interesting area, and we think that we can monitor ship movement in the middle of the sea or near the coast doing illegal activities. And this can be done with thermal imagery, as you can see here as well in the pictures. This is one of our programs that we have here at Aistech. And yes, now is the time for Q&A. Apologies, Pilar.
No problem, Joseph. It was very interesting, so I didn't want to cut you, but I didn't want to finish without this Q&A that I think is very interesting for our delegates. Is the time to ask you really they're wondering and the questions. So we have here a very interesting one asking what is the level of resolution you are expecting in the future and how this will allow us to spot things we cannot spot today. What is this new observation you want to provide with new capabilities?
So at the moment, the best resolution that we can get is around, not us, but the actual systems in space is around 100 meters, and it can be post-processed into 30 meters. We will be half of it on our first satellite, so we'll be at the 50-meter resolution. And with our post-processing, we were expecting to get up down to 30 meters now. So I'm expecting that in the near future, sensors will get better. We will get better, and we hope to get down to better resolution than 20 meters. That is enough for most of the applications that I explained at the end and the markets we tackle.
Perfect. So this links my second question. What application can benefit more from this images with respect to the solution used until now? For example, with Copernicus satellite, with radio and optical bands.
Well, I think that one of the key areas that thermal can actually be used better with a constellation of satellites is all surveillance related areas, such as as I was explaining, like illegal fishing in the sea, cross bordering, and all these things. Plus, every single application related to fire, flooding, everything that's kind of emergency and global warming related. When you have a monitoring of 1 hour unlimited time at the beginning, I can tell you that this is a game changer. The moment you're just talking about days before you have these images, so it's too late for anything you want to do.
Okay, great. So another question, more technical. When analyzing thermal data from space, how you make the difference between atmosphere particles and ground object sources?
But a really good question. So here the atmosphere plays another role than invisible. So most of the data will come from the emitted object that you're seeing. So it's much easier in this case. The atmosphere is more, it's helping you more than on the visible side. And yeah, that's a key factor and one of the reasons why we go into thermal as well.
Okay. A question from our open source lovers. So, are there open data sets available on images coming from thermal infrared bands?
Absolutely. So you can go to most of the already, let's say, finished missions like MODIS or Landsats, even Sentinel. You can just go to the hubs and you can get that data for free. There will be other that I think you have to pay, but yes, there's available data for free. Landsat, I would say, go with the first one.
Okay, thank you. So you said instrument will get better and we will get better. So the question is, what is the biggest challenge today that prevent widespread adoption of infrared imaging?
So the technology itself, I would say, because it hasn't been touched much in the later years, a part of big agencies. I would say technology it's challenging in a sense. So when you're measuring in thermal, it's not like measuring in visible or in infrared. So the techniques for you to characterize your instrument are different. The way that you have to cross-reference your images are different. You are measuring photons here, so you're measuring temperature changes. So it's a completely different technology, and it has, let's say, it's a big unknown in the community. Obviously not for people that works on this, but for the rest, it has been challenging. Me, for example, I come from regular instruments, so in the visible area, and it was challenging at the beginning, and it required some technical background into it.
Okay, thank you very much. So the latest question for today, to understand better Aistech, is Aistech focused purely and only in the thermal infrared imaging, or you have other activities?
It's a really good question. So we have, our focus is on developing payloads. So what we do is basically answering questions from clients. We are really close to the market, and what we try to do is solve issues. So at the moment, we have already 2 satellites flying in space, and both of them have no thermal imager. So they both have 2 different technologies. One of them is pretty famous. It's IoT, Internet of Things. And another one is ADSB, which is an aircraft tracking system, which basically monitors the whole Earth. So every flight that you can see flying above Earth is being observed by our satellite, is being taken. So these are 2 other, let's say, verticals of our business that we are actually, producing clients and giving the solution to our clients. And now our big attention is into the thermal area, and we will launch this imager to solve another issue that we found that was really interesting to tackle, and that we went.
Okay, so in the research of new challenge. Okay.
Yes.
Thank you very much for this presentation. It was very interesting. I can tell from the level of questions. Thank you for being today here. And with this, we close our 4th day of the European Space Generation Workshop. So big thanks to all our speakers. I introduce also David is still here with us. Thank you very much for the big quality of these talks. I think all our delegates highly appreciate, and hopefully we will see you in Space Generation Network in the future in coming events too. Thank you very much. Nice evening to all of you.
Thank you very much,
Thank
Pilar.
you.
Hi, Josep.
Hello, David. How are you?